Dr. Soham, sir?
Yes, Dr. Abhinav, I'm here.
Okay. Can we start, sir?
Yeah, sure.
1 second, sir. Hmm.
Can I share my screen, please?
Oh, just a second, sir. Uh,
Yeah, sure.
okay, sir. So, a very good evening to all present here. So, this is the session 2, day 1 of this Atal AICT sponsored faculty development program. So, today we have with us our speaker, Dr. Soham Datta. So Dr. Soham Datta is a power system engineer with a PhD in electrical engineering from IIT Dhanbad, specialization in power system protection, micro PMU based islanding detection, machine learning, and smart grid technologies. He has experience across academia and industry, including roles as assistant professor and power system engineers, with hands-on exposure to advanced tools such as MATLAB, Simulink, PSCAT, MI Power, Typhoon HIL, and various programming environments. Dr. Soham Datta has an extensive research record with 30 journal publications, 12 conference papers, 4 book chapters, and various granted patents covering intelligent grid monitoring, fault and island detections, renewable integration, microgrid optimization. His work spans simulations, hardware modeling, data analysis, and real-time digital simulations supported by strong communications and mentoring abilities through guiding PhD, MTech, and BTech scholars. So once again, welcome, sir. Welcome to this FDP, and thanks for accepting our invitation on this very short notice. So it's the platform is to you, sir. Over to you, sir.
Thank you, Dr. Abhinav. Good evening, everyone. I will share my screen now. Just please confirm whether everything is working properly or not. Okay. So, is my screen visible?
Yes, sir. It is visible now.
Visible in full screen mode?
Uh, yeah, yes, sir.
And are the
Yeah,
slides changing?
yeah, yes, sir. It is changing, sir.
Okay, sure. Then we are good to go. Okay.
Yes, sir.
Good evening, everyone. So I have divided my lecture into two parts. The first part, I will just brush through machine learning from electrical engineering point of view, not from computer science point of view. And after that, we will see what islanding detection or what is the role of islanding detection in protection. So, what is machine learning? Learning is any process by which a system improves performance from experience. This is a famous quote given by Herbert Simon. Again, the definition of machine learning by Tom Michel in 1998 is given as machine learning is a study of algorithms that improve their performance P at some task T with experience E. Now, these three terms are very important in machine learning, that is, performance P, some task T, and experience E. So, a well defined learning task is given by a combination of P, T, and E. Now, what's the difference between traditional programming and machine learning? So in traditional programming, we have some data, we write some code, and we obtain the output. Okay, we program it in the computer and we get an output. Whereas in machine learning, we give the data, we also specify the output, and the computer gives us a particular program. When do we use machine learning? So machine learning is used when human expertise does not exist. For example, navigating on Mars. So let's say we want to get the terrain. We want to get the terrain of Mars, or we want to analyze the weather on Mars. We want to analyze the electrical signals or some sort of signals in Mars. So it's not possible for human to go on Mars and uh, and collect these signals. And also the expertise on the Mars is not available. So we can use machine learning. Humans can't explain their expertise, for example, in speech recognition. So nowadays in movies, we see that the speech signal is being analyzed through various programs to detect whose speech is it. This is very common in all the detective movies that is now being released. So again, in that all those things we are using machine learning. Models must be customized, for example, in personalized medicine. Then we have models which are based on huge amounts of data, for example, genomics. So these are some of the examples where we use machine learning. A classic example of a task that requires machine learning. So when we are teaching to students, I hope most of the audience here are faculties. So when we check the answer scripts, it's very difficult to, there are some papers where it's very difficult to understand what is the digit that the students have written. So it's very difficult for a normal human being to understand the different type of text which is same. For example, if you will see this green colored line, all these are two, but as a human being it is very difficult to assess which one is two, which one is one, or what is what. But with the aid of machine learning, we can easily identify these common patterns. Some more examples of tasks that are best solved by using a learning algorithm, for example, recognizing patterns, facial identities or facial expressions. So nowadays, again, in movies, we can see so many examples where the criminals is being recognized by their facial identities, by the photos that we acquire from the CCTV cameras. Then we have handwritten or spoken words. Again, when you are using Alexa, we say, "Hey Alexa" or "Hey Siri." So how do they recognize that this is the owner of the mobile phone? Of course, through machine learning. When we are setting up the mobile phone, they ask for 3 times, 4 times voice recognition. So in that way, they are learning. Okay. Then we have medical images. Of course, there are numerous examples of that. Now we can detect cancer at an early stage, or any abnormalities now is being detected at a much earlier stage through the UCG and all those X-rays. So, we just feed it to the machine learning algorithm, and it tells, that the patient might have this probability of getting this disease. Then we have generating patterns, generating images or motion sequences, recognizing anomalies, unusual credit card transactions. Again, for example, when we do some, let's say, a huge amount of purchase from a credit card, immediately we get a call from the SBI or ICICI Bank that, okay, you have done this transaction. Have you really done this transaction? Or, when we are renewing IEEE membership, so it generally goes through I think PayPal or something. Then again, we get a call that, okay, have you done this international transaction? So all these are, they are able to keep track through machine learning algorithm, as it is not possible for human beings to recognize this unusual transaction. Again, we have unusual patterns of sensor readings in a nuclear power. Prediction, again, future stock prices or currency exchange rates. So nowadays there are many, I think, called hedge funds or something, which predict the future stock prices based on the previous market values. So all these are examples of machine learning, which we are using in our daily life. In fact, Geo has come. I'm not promoting anything, but Geo has come out with this BlackRock mutual fund where they're using some Aladdin or something, which is using machine learning to predict. We In terms of electrical engineering, we use machine learning for solar forecasting, wind forecasting. So many. In industry, it is used heavily, I must say. Some other sample applications where we have web search, computational biology, finance, e-commerce, space exploration, robotics, information extraction, social networks, debugging software. Like, name any of your favorite area now. ML, or rather than ML, saying AI is penetrating in each and every applications, be it electrical engineering, be it mechanical engineering, be it be it biotechnical engineering, anything. Then we also have a famous quote by Arthur Samuel, where he defines machine learning as field of study that gives computers the ability to learn without being explicitly programmed. So actually, we are not explicitly programming the computer. It's learning rather than we are programming. It's learning from the patterns, whatever input patterns and whatever output patterns we are giving. So it's learning from those patterns, trying to establish the relation between input and output, and hence we get a machine learning algorithm. Now, as I have told you, there are mainly three things that is with machine learning. That is task T with respect to performance metric P based on experience E. Now, what are this T, P, E? Let's understand with some example. So let's say you are playing checkers. So that is a task that is playing checkers. Then P is the percentage of games won against arbitrary opponent. Then what is the E? Experience, playing practice games against itself. Okay. Then again, uh, the task is recognizing handwritten words. P is a percentage of words correctly classified, and E is a database of human labeled images of handwritten words. Of course, if we don't give the data set of how what are the different variations of twos, then the program will not be able to classify with which things are two. I mean, the example that I have shown you. Then again, driving on four-lane highways using vision sensors, that is a task. What is a P? P is the average distance traveled before a human judged error. E, that is the experience, that is a sequence of images and steering commands recorded while observing a human behavior. So let's see if we want to train a self-driving car. So how we will train? Let's say I want to train it um, in my area. So what I will do, first I will get all the sensors in my manual car, and I will also get a sensor in my steering wheel. And as per uh, the video changes or the image changes, it will record how I am reacting through my steering wheel. From that, it will learn the experience. It will have the experience. Okay, how we will learn, how we will measure that the vehicle has learned from, like, learned effectively. So the distance that is travels without making any error, that shows that how much efficiently we have been able to uh, make the machine learn. Similarly, we can categorize email messages as spam or legitimate. P is a percentage of email messages correctly classified. E is database of emails, some with human given labels. So machine learning, we talk nowadays about machine learning, AI, maybe since 2005, 2006, we have been hearing these terms, but this have been present much before this. For example, this spam, we had this spam mails much before 2000s. So where the program can categorize the emails between spam and non-spam. So that is one of the earliest explanation of machine learning. So it's not that machine learning is very new, it has been into practice, but nowadays it has become more streamlined into all the core engineering branches. Now, what are the state of the art applications of machine learning? We have this autonomous car. So this have sensors, 360-degree sensors. We have some GPS, sorry. We have obstacle detection radars, stereo cameras. So these are all sensors. With the amalgamation of all the sensors, so we are getting a 360-degree view, and that we are feeding it to the program, and it is making decisions. Then we have laser terrain mapping, adaptive vision, learning from human drivers, etc., etc. Nowadays, we also have one term called deep learning, which is again a subcategory of machine learning, where uh, the machine learning is being implemented in a more code level. So this is one of the example where we can label a scene via deep learning. So as you can see, this is the original image. This is the original image, and it has classified all the images into different categories. For example, it has categorized this as road, this as sand, this as car, again this as buildings, this as sky, but it's not necessary that it will detect correctly. For example, if you will see here, it is detecting road, but it is actually a part of the car. Here again, it is detecting road, but actually this is a part of the car. Again, if you will see, this is actually not sand, this is actually water, but it has sometimes, misclassified as sand, this as mountain, it is misclassified as mountain. So it's not necessary that it will give 100% accuracy, but yes, if you will see, most of the labels are accurate. Impact of deep learning in speech technology. Again, when we say hey Siri, hey Google, everything is each one of them are using deep learning in speech technology. Now, very important, especially from the point of classification, when we do any sort of classification using machine learning in electrical engineering, we should know how many types of learning are there. So mainly we have four categories of learning. The first one is supervised, which is also known as inductive learning. The second one is unsupervised learning, where there is no supervisor required. Then we have semi-supervised learning, which is a combination of supervised and unsupervised learning. At last, we have reinforcement learning. So I will deal with the first two, as these are the most prevalent in terms of electrical engineering. Of course, reinforcement learning again is becoming popular nowadays in electrical engineering. So what is supervised learning? As the name suggests, supervised learning is a type of machine learning that learns from labeled data. Labeled data is data that has been tagged with a correct answer classification. I think there is some problem with the slides. It's not getting in full mode. Yeah, now it came. Right. Yeah. Sorry for the inconvenience. Supervised learning, as the name indicates, has the presence of a supervisor as a teacher. Supervised learning is when we teach or train the machine using data that is well labeled, which means some data is already tagged with the correct answer. After that, the machine is provided with a new set of examples so that the supervised learning algorithm analyzes the training data, set of training examples, and produces a correct outcome from labeled data. The best example of this is our classroom, where we prepare a topic and we go to the class, we teach a particular topic, and we solve, let's say, 5 examples. Then we give one example or one problem to the students to solve. So if the student is able to solve, we understand, okay, that means I have taught properly and the students have received it properly. So the task is done. The performance is good. So the task is done. Okay. But what if the student is unable to do? Then we give another example or another problem. We will again show 3-4 examples, and then again we will give one more sums to solve. If they are able to solve, that means they are learned. So it's basically supervised learning. We are a supervisor and we are making them learn in the presence of a supervisor. Okay, so that examples that we are solving. So what we are doing, we are giving the question, okay, this is the thing you have to do. And we are also giving the solution. So we are also giving the labeled output that this is the solution. Okay, so we are giving the problem also, that is an input also. We are giving the solution also, that is the output. So input and output, when both is given to a computer and the computer is expected to learn from that, it is called supervised learning. Okay. For example, a labeled dataset of images of elephant, camel, and cow would have each image tagged with either elephant, camel, or cow. So let's say we have a labeled data. Okay, we have a labeled data where these are labeled as cows, these images are labeled as elephant, and this brown things are labeled as camel. Okay, then we have a supervisor. We will give this training data set. We will also give this desired output. Then the algorithm will run, it will process, and it will give the output. Okay, now what will it process? So from these things it will learn, and whatever it has learned, it will apply on this new data sets. It will apply on this new data set, and based on this learning, it will classify this new data set into elephant, camel, and cow, or multi classes. Whatever classes are available, it will classify. Okay, so again, I'm explaining as my second part, that is my actual islanding detection part, is based on this only, where I will be giving the labeled input data. I will also give the, sorry, I will give the input data, I will give the output data. From those two things, it will develop the algorithm. After that, I will feed some new data. Then, based on the learning, it will classify the new data into the respective classes. Okay, is it clear? Okay. So what are the key points? Supervised learning involves training a machine from labeled data. Labeled data consists of examples with correct answer or classification. The machine learns the relationship between inputs, for example, let's say fruit images, and outputs, fruit labels. The trained machine can then make predictions on new unlabeled data. Okay. So again, let's give another example. Let's say you have a fruit basket that you want to identify. The machine would first analyze the image to extract features such as its shape, color, and texture. Then it would compare these features to the feature of the fruit it has already learned about. Now, this is very important. So let's say we have taken the example of, okay, apple, banana, and let's say we can take pineapple example. So when we will continuously feed the images of apple, banana, and pineapple, so what it will try to extract the features of every fruit. For example, the apple will be somewhat round in shape. Okay, so that is one of the feature. The banana will be somewhat longitudinal in shape or cylindrical in shape. That will be that is feature, and the pineapple will be somewhat what to say oval in shape. Okay, so this is one of the feature based on which it will classify the three apples. Another can be the color. For example, apple is red in color, banana is yellow in color, pineapple is orangish in color. So based on the color, it is differentiating these three fruits. So again, this color is a feature. Okay, so it's very important to understand terminology. What is input data? What is output data? What are the features? Okay. So if the new image features are most similar to those of an apple, the machine would predict that the fruit is an apple. Okay, so for example, if the new image that we are giving it to the machine learned model, if the image is somewhat roundish in shape, somewhat red in color, then it will classify as apple. Okay, it is not so much easy, but at a granular level, it works like that. For instance, suppose you are given a basket filled with different kinds of fruits. Now, the first step is to train the machine with all the different fruits one by one like this. If the shape of the object is rounded and has a depression at the top, is red in color, then it will label as apple. So this depression, red in color, all these are features of the fruit apple. If the shape of the object is a long curving cylinder having green yellow color, then it will labeled as a banana. Okay. Now suppose after training the data, you have given a new separate fruit, say banana, from the basket and asked to identify it. Since the machine has already learned the things from previous data and this time has to use it wisely, it will first classify the fruit with its shape and color and would confirm the fruit name as banana and put it in the banana category. Thus, the machine learns the things from training data and then applies the knowledge to test data. Okay, but again, this training process should be continuous in process. For example, let's say red banana is very common in where I'm currently staying in Telangana. It was also very common in. It is very also common in I think Tamil Nadu, where we get red banana. Okay, so suppose we give a red banana to it, then it can classify as banana or it can classify as apple. It will get confused because it is red in color but longitudinal in shape. So it will get confused. It may give incorrect result. So what we have to do? We have to train it again with some red bananas. Okay, we have to, let's say we have to feed to it the 100 images of red banana, then it will get updated. Okay, some red in color but longitudinal shape is also a banana. So all this, I will try to connect all these concepts in the second part of my PPT when I will be dealing with the identity detection part. So these are the types of supervised learning. Now with with supervised learning, we can do either regression or a classification. Okay, so a regression problem is when the output variable is a real value such as dollars or weight. A classification problem is when the output variable is a category such as red or blue, disease or no disease. First, we'll understand what is regression. So regression is a type of supervised learning that is used to predict continuous values such as house prices, stock prices, or customer churn. Regression algorithm learn a function that maps from the input features to the output value. Okay, so we have done. You remember we have when we do experiment in labs. Okay, when we do experiment in labs, what do we say to the students? That join the dots or make a line which is passing through maximum dots. So that is regression. That is simple regression. Okay, so regression algorithms learn a function that maps from the input features to the output value. Then after that, if we extend the line, whatever graph we have made, if we extend that line, then we can also find out that what is the probable value, output value for a given input value. Okay, so that is called regression. Now, some common regression algorithms include linear regression, polynomial regression, support vector machine regression or SVM regression, decision tree regression, that is DT, and random forest regression. Then we have classification. So classification is a type of supervised learning that is used to predict categorical values such as whether a customer will churn or not, whether an email is spam or not, or whether a medical image shows a tumor or not. Okay, so either it will be this class or that class, yes or no, A or B, 1 or 2, like that. Classification algorithms learn a function that maps from the input features to a probability distribution over the output classes. Now, these are some common type of classification algorithms. We have SVMs, we have DTs, we have random forest, we have naive Bayes, we have many more. But these are the most commonly used machine ML algorithms. So what are the application of supervised learning? It is used in spam filtering, image classification, medical diagnosis, fraud detection, NLP, which is again like there are many words going in NLPs in computer science engineering. NLPs as such is not used in electrical engineering, but of course for computer engineering it is it's a hot research area. Now, what are the advantages of supervised learning? It allows collecting data and produces data output from previous experiences, helps to optimize performance criteria with the help of experience, helps to solve various types of real-world computational problems, performs classification and regression tasks, allows estimating or mapping the result to a new sample, complete control over choosing the number of classes we want in a training data. So it's not that it only does binary classification, it can do multi-class classification also. What are the disadvantages? Classifying big data can be challenging. So if we have, you know, lakhs and crores of data, then it will become somewhat uh, difficult to assess all those things. Training for supervised learning needs a lot of computation time, so it requires a lot of time. Supervised learning cannot handle all complex tasks in machine learning. It requires a labeled dataset, which is very, very important. Every time we will not have a labeled dataset. Okay, we might have a non-labeled dataset also. It requires a training process. But of course, that is the essence of machine learning. Now we will see sorry, what is unsupervised learning. So unsupervised learning is a type of machine learning that learns from unlabeled data. This means that the data does not have any pre-existing labels or categories. The goal of unsupervised learning is to discover patterns and relationship in the data without any explicit guidance. Unsupervised learning is a training of a machine using information that is neither classified nor labeled and allowing the algorithm to act on that information without guidance. Here, the task of the machine is to group unsorted information according to similarities, patterns, and differences without any prior training of data. So the practical example of unsupervised learning is our Facebook or Instagram or YouTube. So let's say suddenly we become interested in yoga. Okay, so we will search different yoga pose, yoga techniques. After that, suddenly you will see that a yoga mat is popping up in your Amazon, that okay, buy your yoga mat. Then you will get all the health supplements. Okay, take this protein shake. Okay, so all these healthier, so-called healthier things will come into your display, be it in Facebook, be it in Google, whichever app you open, these things will pop up. So these are all unsupervised learning. Okay, so the things that you are searching, it's not labeled in a true sense, but it is learning from your history, from your search history. Okay, that you are moving towards this, so it will recommend you all those things. Okay, so this is called unsupervised learning. So unlike supervised learning, no teacher is provided. That means no training will be given to the machine. Therefore, the machine is restricted to find the hidden structure in unlabeled data by itself. So again, another example, I mean, classroom example, as we are talking in faculty development program. So in classes, when we scold the children, okay, when we scold the children, if we are new to the children, they will take it very seriously. But if we take 1-2 semesters, after 1-2 semester, when they go to third year and fourth year, they will understand, okay, okay, this teacher is not so strict. Okay, so they will automatically label us as this is not so strict, this is a very friendly teacher. So this is called unsupervised learning. We have not labeled the data that okay, we are strict or we are very friendly. It is them, through experience, they have labeled us. So that is a a good example of unsupervised learning. So you can use unsupervised learning to examine the animal data that has been gathered and distinguish between several groups according to the traits and action of the animals. These groupings might correspond to various animal species, providing you to categorize the creatures without depending on labels that already exist. So let's say now again we are taking the same data set, okay, where we have elephant, where we have camels, where we have cows, but we are not labeling it. Okay, like this is the image of elephant, this is the image of camel, this is the image of cow. So what it will do, it will do interpretation. What interpretation will it do? That okay, if it has a trunk like this, if it has a trunk like this which is going downwards, okay, a projection which is going downwards, then it is one type of class. Okay, and also it is black in color or gray in color. In the images which the projections are going upward, those, and is brown in color, those are another set. Another set where we have patches of black and white, and there is no such narrow projections coming out, it will classify it into another image. So in this way, it will try to interpret, it will try to do the algorithm, it will process it, and then it will automatically split the data the data into several classes. So what are the key points? Unsupervised learning allows the model to discover patterns and relationship in unlabeled data. Clustering algorithms group similar data points together based on their inherent characteristics. Feature extraction captures essential information from the data, enabling the model to make meaningful distinctions. Label association assigns categories to the clusters based on the extracted patterns and characteristics. Now we will understand with an example. So imagine you have a learning model trained on a large data set of unlabeled images containing both dogs and cats. The model has never seen an image of a dog or a cat before, and it has no pre-existing labels or categories for these animals. Your task is to use unsupervised learning to identify the dogs and cats in a new unseen image. For instance, suppose it is given an image having both dogs and cats which it has never seen. Thus, the machine has no idea about the features of dogs and cats, so we can't categorize it as dogs and cats. But it can categorize them according to their similarities, patterns, and differences. That is, we can easily categorize the above pictures into two parts. The first may contain all pics having dogs in them, and the second part may contain all pics having cats in them. Here, no prior learning is done, which means no training data or examples. It allows the model to work on its own to discover patterns and information that was previously undetected. Again, we have several types of unsupervised learning, that is clustering. A clustering problem is where you want to discover the inherent groupings in the data, such as groupings customers by purchasing behavior. Then you have association and association rule. Learning problem is where you want to discover rules that describe large portions of your data, such as people that buy X also tend to buy Y. The same thing that I've told you for yoga. If you're buying yoga mat, then there is a probability that you will also buy this yoga, this protein supplements and all those things. Okay, so that is called association. You associate X with Y with help of unsupervised learning. So clustering is a type of unsupervised learning that is used to group similar data points together. Clustering algorithms work by iteratively moving data points closer to their cluster centers and further away from data points in other clusters. These are several types of clustering types. We have hierarchical clustering, K-means clustering, PCA, that is principal component, is very important, principal component analysis. Singular value decomposition, you will find many papers on that. Independent component analysis, Gaussian mixture models, density-based spatial clustering of application with noise, so on and so forth. There are many methods. Association rule learning is a type of unsupervised learning that is used to identify patterns in a data. Association rule learning algorithms work by finding relationships between different items in a data set. Some common association rule algorithm include a priori algorithm, ECLAP algorithm, FB growth algorithm. So these are the application of unsupervised learning, where we can have anomaly detection, scientific discovery, recommendation systems, customer segmentation, which is actually they use in Facebook and Insta. So identify group of customers with similar characteristics, allowing businesses to target marketing campaigns and improve customer service more effectively. This has been increasingly used in whatever app you're using. Whatever app you're using, it is doing this. So yeah, I mean, data is the new oil, and the data is everywhere. I mean, data is being leaked everywhere. Okay, so then we also have image analysis. What are the advantages of unsupervised learning? It does not require training data to be labeled, capable of finding previously unknown patterns in data, good at finding patterns and relationships in data without being told what to look for. What are the disadvantages? Difficult to measure accuracy or effectiveness due to lack of predefined answers during training. So, okay, in the example that it has distinguished elephant, cats, and dogs. So, if we don't know that, okay, these classes are called this, then it is very difficult to measure the accuracy. Okay, let's say we have a completely new data set. It has classified the data into several classes, but what those classes actually indicate, okay, or they are accurately classified or not, it is very difficult to assess in terms of unsupervised learning. In terms of supervised learning, it was very easy because we had the labeled data already. So just we will be comparing it. Okay. So the results often have lesser accuracy. The user needs to spend time interpreting the and label the classes which follow that classification, which I explained just now. Unsupervised learning can be sensitive to data quality, including missing values, outliers, and noisy data. Without labeled data, it can be difficult to evaluate the performance of unsupervised learning models, making it challenging to assess their effectiveness. So, ML in a nutshell, tens of thousands of machine learning algorithms come every year. Every ML algorithm has three components: representation, optimization, and evaluation. These are the various function representations. We have numerical functions, symbolic function, instance-based functions, probabilistic graphic models. Then we have various optimization algorithms, for example, gradient descent, dynamic programming, or TP, commonly known, divide and conquer, evolution algorithm. So we have GAs, GP, neural evolution, etc., etc. Now, how will you know that the machine has learned properly or not? It is based on accuracy, precision, and recall. Again, we will be revisiting these terms when I will go to the second part. Square error, likelihood, posterior capability, cost or utility, margin, entropy, KL divergence, etc. So how will you do the ML in practice? So understand domain, prior knowledge and goals, data integration, selecting, cleaning, pre-processing, etc. Learn models, interpret results, consolidate and deploy discovered knowledge, and it goes in a loop. As I have taken the example of that red banana. Okay, so as the scenario changes or as the data changes, we have to continuously feed them to the machine learned algorithm so that it continuously update itself. So these are the lessons learned about machine learning. Learning can be viewed as using direct or indirect experience to approximate a chosen target function. Function approximation can be viewed as a search through space of hypothesis for one that best fits a set of training data. Different learning methods assume different hypothesis spaces and or employ different search techniques. So that's for my first part. So before moving to the second part, any question from the first part? It's okay if there is no question because I will just start with the second part, or we can just take a 5 minutes break. If is it okay, Dr. Aminov, if we take 5 minutes break before going to the second slide? I mean, second part. Okay. Just we will take a 5 minutes break and then we can resume again.
Soham sir,
Yes.
any issue, sir?
Not an issue. I was just wondering whether we can take a 5 minute break or not before I start with the second part.
Okay, no issue. You can take a break, sir.
Yes, yes. Let's take a 5 minute break. After that, we will
Okay,
start.
okay,
Thank
fine,
you.
fine. Okay.
Okay. Now we will continue with the second part, that is islanding detection approach in microgrid with machine learning. So this is a typical power system island scenario. So let's say this is a main grid, okay, and this is connected with the I mean with the all the DGs. Here DGs means distributed generators. Okay. Now suppose there is one instant when this circuit breaker opens. Okay, then what will happen? This part will get segregated from the main grid. Will get segregated from the main grid, but this part will still be energized. These loads will still be energized by their respective DGs. Okay, so this is called an islanding concept. Okay, so this part is being islanded. Okay, it is disconnected from the main grid, but it is still, the loads are still being energized by the respective DGs. Now, there are two types of islanding. One is intentional islanding and one is unintentional islanding. Okay, so intentional islanding is when we do that in a planned manner. So whenever the utilities do anything in a planned manner, that is not a problem. Okay, they take all the precautionary measures and then they go for planned outages or planned islanding. Okay, the problem arises when there is unintentional islanding. So let's say due to anything, due to any unprecedented or unplanned situation, this gets opened. Then what will happen? There are several things which necessitates for islanding detection or unintentional islanding detection. The first one is personal safety, hazardous for utility workers. So the main grid will tell the workers, okay, you can go and work in this area. So they will be unaware that these loads are still energized or these lines are still energized by these DGs. So what may happen is that they may get seriously electrocuted. Then we have a problem of over voltages. So voltages can exceed 173% during fault. Reconnection out of phase. So if we reconnect it, and if it is out of phase, then a huge circulating current will flow, which will damage the equipments. Unsuitable power reliability for loads. So there will be a confusion between IPPs or independent power producers and utility for the culpability for degraded power quality. So in broad terms, islanding detection methods um, can be categorized into classical and modern. In classical, we have passive, active, hybrid, and local. In modern, we have signal processing and classifier, that is a machine learning classified methods. Now, this is a simple diagram of micro PMU. So it is generally we are all accustomed. I mean, we all know what PMU is. Generally, it is used in transmission line, but micro PMUs are used in distribution side. Okay. So, what is the motivation for the research area that I am currently working on, or I was working on? So, problems of PMU dependent methods, estimation of phasors consume some time, highly dependent on the communication channel, reference phasor and frequency. Problems of methods that does not employ PMU, external arrangements required. So for this, an amalgamation is needed. Micro-PMUs have high sampling rate, a proper data analysis is required, and reliability, software reliability of island detection algorithm is needed. Now, since we have less amount of time, I will just go and into the machine learning part. Yeah. So let's say we have a working of a traditional micro PMU. Okay, so this is a traditional of a working, traditional working of a traditional micro PMU. We have the microgrid, where the micro PMU measures all voltage and currents, and it sends the phasors to a control center, where it analyzes the condition of the grid or the microgrid based on these phases, and it sends the appropriate phases. Okay, sorry, appropriate controls. So what I've done is that I've used a signal processing method called spectral kurtosis. Okay, so this is my system. This is rest of the grid, and this is the microgrid. So this is a modified IEEE 30 node active distribution network. Okay, so I have connected a local load, a solar generator, and a micro PMU at node 660. Okay, Now, what I have done is that I have analyzed the voltage at the SG bus. So I have analyzed the voltages that is acquired by the micro PMU, okay, with spectral kurtosis, and we are obtaining this graph. This is called normalized frequency, and this is a kurtosis value. So as you can see, this is for normal scenario, this is for islanding scenario, and this is for fault scenario. So you can see that the transient nature is different in different conditions. Okay, so from this we can see that uh, that it can be that if we have many data, then we can categorize these events into fault, islanding, and normal scenarios. So for that, for data generation, what I have done is that I have taken uh, this cases of islanding where I am varying the power mismatch from plus 40% to minus 40%, reactive power mismatch from plus to minus 40%, and there are some scenarios where I have varied both. Then I have considered fault cases, 180 fault cases of LG, LLG, LL, and triple L fault with fault resistance ranging from 0 ohm to 100 ohm. Then we have the capacitor switching with values ranging from 150 kVR to 350 kVR. And finally, we have load switching with values ranging from 150 kilowatt to 350 kilowatt. All this I have done to generate data, because without data, we can't go for machine learning, especially um, supervised machine learning. In my research, I have used supervised machine learning for classification purpose. Okay. Now, if we take these features F1, F2, F3, F4, F5, what is F1? SK coefficient at normalized frequency of 0.1. That is, I am taking the value corresponding to this 0.1, 0.2, 0.3, 0.4, and 0.5. So that's why I'm getting these 5 features. Okay. You remember in the first part, I have spoken about features of the fruits, where those are being distinguished based on color, based on shape, okay, based on size. So these are the features. These are the features of the machine learning. So I have plotted these features. I have plotted this F1, F2, F3, F4, F5 features for fault scenarios, island scenarios, and normal scenarios. And I can see that these values are actually different. This is just for the graphical representation, that these values are actually different for all the different cases. Now here I have used random forest classifier as machine learned classifier. Okay. So you can see the accuracy of classifier to show the importance of each feature. Okay, so this is the feature we're not consider. So if I don't consider F1, then random forest we are getting 95%, decision tree we are getting 93.3, SVM 63.3, ANN 75.2, average 81.7. Similarly, I have done for F2, F3, F4, and F5. From this, I can see that F1, F2, and F4 has good random forest classification. Okay, and from this table also we can see that random forest is giving the most accurate results. Okay, then I have also classified accuracy for different number of features. I have taken all the features like with 5 features, and I have taken 3 features, that is F1, F2, and F4. So I can see that for random forest, when I'm considering 3 features, the accuracy is actually improving. Okay, so all this you have to note down while you are doing a research. I have then plotted the confusion matrix for RF classifier, and I have done the flowchart of the proposed algorithm. So what it will do, it will obtain the voltage data of SG bus. It will perform spectral kurtosis for data obtained in 8 milliseconds. It will record the extracted features, that is F1, F2, and F. Sorry, I forgot F1, F2, and F4. Then it will feed the SG voltage bus features to RF classifier. If it detects abnormal condition, then it will see whether islanding is there or not. If it is there, then it will send island occurrence signal, and it will take the appropriate control measures. If it is not detected, then it will again go back to the like obtaining the voltage bus. Now, what I have done is that I have taken some test cases, some new. You remember in the first part, I have told that we will give some new images. So here I am giving some new values, some new test cases. Those are called test cases. Okay, where I am varying, I am giving this condition where I am varying this load from this to this, and I mean the power mismatch is being varied. We are obtaining these features F1, F2, and F4. And as you can see that after proper training, it is being able to classify this island features. Okay, so table 4 is algorithm classification result for active power mismatch. Table 4.5 is algorithm classification result for reactive power mismatch. Okay, again I have varied the fault resistance, as well as the fault types. Okay, the fault types, these are the features, that is F1, F2, and F4. And you can see that it is being able to detect the fault accurately. This is based on fault inception angle FIA, and this is algorithm classification for different power system operations. Okay, so there are many operations which generally get confused with the transients. For example, capacitor switching, huge load unmasking, induction motor starting, so on and so forth. Okay, and as you can see in all these things, it is able to detect fault. Now, what is the effect of noise? Very important whenever we are measuring any voltage, any signals. Whenever we are measuring any signals, so uh, like for as we increase the noise, the accuracy level decreases. Okay, so noise also plays a role uh, in machine learned examples. Okay, in machine learned problems. This is the algorithm time that I have calculated, and yeah, I have. Whenever you write a paper, you should always compare it with the available papers which are already available in literature. So these are the things that I've got. So as you can see, for the proposed for the proposed method, we have got 20 millisecond as detection time, and for the proposed classification, we are getting 99.83% accuracy. So I will just skip all this. Uh, so future work includes real records generated from real or practical grids during islanding instance, may augment the reliability of the methods. Okay. The effect of fast capacitor charging on different IDMs introduced due to huge number of electric vehicles in future grids may be analyzed. So as you know, the electric vehicles are gradually penetrating into grids. Okay, so what will be their effect on islanding detection? It is still not uh, being explored, or explored very lightly, very insignificantly. So that is another research area which can be worked upon. The another one is chances of cyber attack on the proposed algorithm is another concern. This calls for a cyber secured island detection approach. So you can also delve into cybersecurity aspect of smart grids. So that's it for my second part. Now, any question, I will be happy to answer.
Yeah, thank you so much, sir, for giving this wonderful presentation, sir. So, is there any questions from the participant side? You're most welcome. It was really a nice presentation, and it's like an implementation of AI ML in the real-time system here. It will definitely help you to in your research and academic works.
Yes, yes. Thank you, Dr. Abhinav. Is there any question that you want to ask from the industry aspect? Any research scholars who want to go into industry? Do you need any input? Or faculties, those who want to give input to the students, like which aspects to work upon to get into the industry? As I've shifted from academics to industry, I think I can answer that question um, accurately. Is there any question regarding that?
Yeah, any participants?
Okay,
So,
if there
sir,
are no questions,
no,
yes,
no issue, sir.
sorry.
If if there is no question from the participant side, so let me ask a question, sir. So, as you told that you have moved on from academics to this industry, so what is the basic difference you feel? Normally, we say that it's like a difference between theoretical and practical approach. So, how will you, sir, share your experience regarding this?
My experience is that you need, for industry, you need a basic understanding of power system. It's not that you need a detailed understanding of power system. As you enter into the industry, gradually you will learn. Okay, and what we study in academics, okay, the conditions are not so much ideal in industries. Okay, and we have to follow some standard practices which we can't ignore. Okay, so if, let's say, if the frequency bandwidth is 0.5%, then we have to maintain that 0.5%, and it depends from grid to grid. Okay, and another thing which I would suggest to faculty members to encourage students. So there are two direction students can go, or PhD scholars can go. One is analysis part, power system analysis part. Another one is power system coding part. So right now I am working on the coding part. Okay. So if you want to go to the analysis part, two softwares which is very important. One is PSCAT, one is EMTP. Okay. I mean, if you are teaching in labs, please ensure that students are working on PSCAT and EMTP software. These two are very much used in industry. Okay. And if you are going to the coding part, make sure you learn Python, you learn JavaScript for front end, you learn C sharp. If you master these three things, I am very definite you will get a very good position in power system industry.
Okay, sir. Thank you so much for giving this wonderful response. So let we wind up this session. So on behalf of Department of Electrical Engineering, JCBUST YMCA Faridabad, I, Dr. Abhinav Saxena, give us sincerely thanks and gratitude to our eminent speaker for your valuable insight and engaging session during the whole session. Definitely, your expertise and explanation with real-world example greatly enhance the knowledge and also increase the learning experience for all the participants. Your talk has undoubtedly inspired new perspectives among our faculty members and all the research scholars here. We truly appreciate your time and efforts you dedicated for preparing and delivering a valuable sessions. Thank you, sir, once again for contributing to the success of our session. Thank you so much, sir.
Thank you. It's been my
Uh,
pleasure to give a
Yeah,
talk. Thank you, everyone.
yeah, yeah. Okay. So just hold on, please, sir. Let's have a group photo.
Sure.
Vinayak, are you there?
Okay, I'm not properly dressed.
No, should no, should it's good, sir. Vinayak, are you
Sure.
there?
Yes, sir.
I request all the participants, please switch on your camera, please, for the group photograph. Vinayak, please let me know once it is done.
Yes, sir.
Okay. Thank you so much, sir. Thank you for giving your time on a very short notice.
Pleasure. Pleasure.
Okay.
Thank you. Thank
I'll
you.
connect you, sir. Further.
Sure.
Thank you, sir.
Bye.
If you want,
Bye,
you
everyone.
bye, sir. Bye. I request all the participants, please be connected. Okay. So I'm sharing this feedback from for this session on the WhatsApp group as well as the chat session of this Google Meet. So you have 1 hour time to complete this uh, feedback form. So feedback form has been shared on the WhatsApp group as well as on this chat box as well. So you have 1 hour time. So participants, so we are closing this day one of this day one program of this faculty development with this two sessions. So tomorrow we will meet at 6 p.m. for the session 3 and session 4. Okay, so it is requested to kindly join by 6. Okay, thank you so much. So it is just make sure that be regular in this FDP and maintain your 70% attendance by attending this and also submitting this feedback form regularly. So at the end of this FDP on the last day, you have to also attend a test that is based on objective one. Okay, thank you so much. विनायक,
यस सर,
उसको ऑफ कर दीजिए, ठीक है,
श्योर,
इसको डिस्कनेक्ट कर दो।
ओके सर।